Hi, my name is Heidi Hanson. I'm a life course epidemiologist and demographer at the University of Utah. Today I'll be talking about building an exposomic data resource. This data resource is being developed so that we can understand contextual factors that lead to disease. We are merging many different data sources across space and time, which will allow us to investigate environmental exposures across the life course. This exposomic data can then be combined with other forms of data, such as familial or molecular data, to help us improve our understanding of the etiology of disease. In this figure, you see on the left-hand side a pedigree, and on the right-hand side, a map of Salt Lake County, Utah. The phenotype in question is BMI, with red representing higher BMI and blue representing lower BMI. If you were to only glance at the pedigree, you may assume that high BMI is genetic and travels in certain branches of the pedigree, and low BMI may be genetic and brought in by an outside family member. However, when you combine this information with information on residential history, you can see that this story may be much more complex, with environmental exposures leading to the familial patterns that are displayed on the pedigree. So what exactly is the exposome? It's a measure of environmental exposure across the life course. Carcinogenic exposures can come from multiple sources, and measures of the exposome require merging this data across time and space. In addition to creating a data tapestry of environmental exposures, measures of social determinants of health should also be incorporated. This allows us to construct a full picture of the contextual factors that shape disease risk across the life course. A key component to doing this is constructing residential histories from birth to death. This allows us to develop longitudinal measures of exposure at the individual, neighborhood, and societal levels. In order to do this, information from historical censuses, administrative records such as birth and death certificates, can be geocoded and allow us to begin to construct a history of residence for individuals in our studies. My lab has started this process by constructing multi-pollutant measures of ambient air pollution exposure from 1990 to the present. This will allow us to assess the effect of environmental exposures for up to 30 years prior to cancer diagnosis. This is a latency period that is relevant for many different cancer types, including lung and bladder cancers. There are many other publicly available data sources that can be used to construct measures of environmental exposure across a long period of time. We have recently received funding from the Huntsman Cancer Institute to increase our own efforts and incorporate additional measures of possible carcinogen exposure across the life course. These factors will be combined with publicly available measures of social determinants of health to create measures that will allow us to take a deep dive into the complex interrelationships between these factors and their influence on health outcomes. Data processing and curating are important steps in creating measures of environmental exposure across the life course. While many of these data sets about environmental exposures are publicly available, special attention to the sparsity that exists both temporally and spatially is necessary. The analysts need to be aware where the data points are missing and any of the associated biases that exist with those missing data sets. In addition, the appropriate models for estimating exposure are necessary and often take a lot of computational resources to estimate the appropriate exposures. Once the individual metrics have been estimated, they can be combined together and measures of multi-pollutant exposure can be created. Many different exciting things are happening in this field right now, and I am very excited to see what happens in the next few years in identifying how the environment leads to health outcomes. In conclusion, health development is complex and involves both genetic and environmental factors and their interactions. Combining data from a vast number of sources with machine learning methods can help us make sense of the interdependent genetic and environmental factors that shape health. By embracing this complexity, we can come up with new ways to both prevent disease and treat it once it occurs.